Welcome to solverfy.
In question 80, we're given the two molecules ethylene glycol, which I have here on the left, and pentane, which I have here on the right. And it says both are liquids at room temperature and room pressure and have about the same molecular weight. Question A says one of these liquids is much more viscous than the other. Which do you predict to be more viscous? Well, increased viscosity is associated with increased intermolecular forces. So the stronger the intermolecular forces, the more viscous your fluid is in general. And so let's look at our molecules here. Starting with pentane is just carbons and hydrogens in a fairly symmetric formation, and therefore this is going to be a nonpolar molecule. And so the only sorts of intermolecular forces the pentane is going to have are London dispersion forces. My ethylene glycol, however, has two OH groups on it, one on each end, and these OH groups are going to allow it to form hydrogen bonds, and in fact, two hydrogen bonds per molecule. Now, it can also have London dispersion forces, but the London dispersion forces are going to be fairly comparable because they have similar molecular weights. Therefore, it's the hydrogen bonds that are really going to affect viscosity in this case. Those stronger intermolecular forces of hydrogen bonds are going to increase the viscosity of that liquid. Question B says one of these liquids has a much lower normal boiling point compared to the other. The other one is at 198 Celsius, so which one's going to have the lower boiling point, normal boiling point? So again, lower boiling point is going to be associated with weaker or fewer intermolecular forces. And so pentane not only has fewer intermolecular forces, it only has London dispersion versus hydrogen bonds and London dispersion, but London dispersion forces are not nearly in general as strong as hydrogen bonds. Therefore, the lower boiling point is going to be the pentane. And part C, and this one was the ethylene glycol. Part C says one of these liquids is the major component in antifreeze in automobile engines. Which liquid do you expect to be used in antifreeze? So you may or may not be familiar with this molecule because it is the major component of antifreeze. So the answer is ethylene glycol. But let's talk about why. Because ethylene glycol has these OH groups, it can form intermolecular forces with water, which also has obviously OH groups, and therefore it's going to be miscible with water. So it's going to mix with the water because it can form those intermolecular forces, those hydrogen bonds with the water. And since it's mixing with the water and it has a much lower melting and boiling point than water, it's going to bring down the overall melting and boiling point of it's going to be lower than water, this mixture of the two. So the fact again that it can hydrogen bond allows it to mix, it's miscible with water, and then the fact that it has a lower melting and boiling point means that the mixture of water and ethylene glycol is going to have a lower melting point and boiling point. But for antifreeze, it's the melting point that we care about. We're trying to keep it from freezing. Question D says one of these liquids is used as a blowing agent in the manufacturing of polystyrene foam because it's so volatile. Which liquid would you expect to be the blowing agent? Okay, well, volatility, if something's volatile, that means it easily becomes a gas. And it easily becomes a gas if if it has weak intermolecular forces holding it together. So the weaker the intermolecular forces, the easier they are to break and go from a liquid to a gas. And so the weakest intermolecular forces belong to pentane with just those LDFs. So we would expect pentane to be used as the blowing agent.